Hi everyone, we're back. Thanks for hanging out with us here. We have a very, very special guest now, Tom Chi, one of the creators of Google Glass. Tom is brilliant. He's an advisor to the Hack Summit. He's a personal friend of mine, and he's just a wonderful human being. Not only has he excelled at the pinnacle of success at Google, helping create Google Glass, but he also is a mentor and advisor at the Unreasonable Institute. Tom spends an enormous amount of time giving back to helping good causes. He spends a lot of work in developing countries, helping to provide energy to those countries. And so he's truly a pinnacle of both a strong businessman, a good technical leader, as well as a good human being that gives back. We're very grateful to have him here today. Tom will be speaking today on iterating on your projects, and he'll teach you some of the best practices that he learned at Google. After Tom's talk is over, we'll be awarding a free mentoring session with Tom or the other participating speaker of your choice. We'll hang out here, ask lots of questions. The audience member who asks the #1 question with votes is going to win that free session. So Tom, I'll let you take it away from here. Thanks, Tom.
All right. Hey, everybody. So that was a pretty intense introduction. I will try to lower everybody's expectations now. I'm Tom Chi. And I want to talk to you a bit today about the way that we worked on projects in Google X. And it was really quite different. In a way, like even though Google is this huge company, and huge companies move projects at a particular speed, within Google X we're able to move tremendously faster than a big company, and actually really tremendously faster than even the world of startups. And I will share a bunch of those ideas today so that you guys are able to hopefully put them into practice in your own projects. So here we go. So title of the presentation is Rapid Prototyping X. This is kind of a work methodology that has a bunch of specific kind of practices, but also they contain a thing that I call psychological debugs, because a lot of what prevents us from moving very quickly is different things around our own psychologies of how we work. And to give you a sense of how quickly we were able to work in Google X, when I started there was about 10, 12 people in the group. I was the head of product experience, so I was on the leadership team from the very beginning. And in less than 2 years, we had produced the self-driving car, Google Glass, continuous glucose monitoring contact lens, a network of balloons called Project Loon that's meant to provide internet to every square inch of the Earth, a new approach to artificial intelligence called semi-supervised learning, a technology that allows you to walk around indoors with a cell phone and automatically create 3D maps of the space, couple other things that are unannounced, and also spun out a couple companies. And all of that was created by a group just starting with about 10 people in less than 2 years. Now, and these aren't like software builds. All of these were pretty significant hardware builds. So we were working with something that tends to be more material and a bit slower. Now, there's other proof points. Well, I'll get to those proof points in a second. But if you look across the top, there's a number of projects, and actually a lot of the working methodology I developed while I was working as an executive at Yahoo, even before I came to Google. But with that, let's just jump right into it. Okay, so the first mental debug is knowing the difference between guessing versus direct experience. So, I got to Google as my first day of work. This is obviously a picture of Google Glass, but there was no Google Glass on my first day of work. What there was a half-page document from Larry and Sergey, and it said something like, what would it take to have Google in your brain? And what they meant by that, out of anything nefarious, is that as soon as you want to know something, then you immediately know it. And obviously there's many ways that you could go approach that. You could try to do brain implants and all these sorts of things, though I could talk a lot about brain implants. They are not really effective at this particular stage in technological history, so I would not advise them unless you have some therapeutic thing that you need to do with them. But we got basically this half-page brief from Larry and Sergey that kind of challenged us to go invent a way to have Google in your brain at any given moment. And we got together that morning to kind of discuss what that might look like. And pretty quickly we thought about the idea of a heads-up display, because that's a very kind of technically achievable thing that you can do to achieve the larger why. But quickly that meeting went from an exciting meeting in my first day of work to actually like kind of a bad meeting, because we had really brilliant people in the room. Like Sergey was there. There's a lot of PhDs there that were there. It was just like the founding team was like really high caliber people. But halfway into that first meeting, we were already just guessing at each other. And the thing that we were guessing about was what color should the display be on the heads-up display, which is ultimately a ridiculous question to be asking on the very first day of a project. But worse yet, we were arguing about it. Just, and everybody was taking a strong position, and ultimately the person who won that argument was the person who usually wins the argument. So typically the people that win those sorts of arguments where people are just guessing at each other are either the person that is best at arguing or the person that has the highest title in the room. And in this case, it was the same person. It was Sergey. And Sergey was 100% convinced that the color of the display needed to be red. Now, I left that meeting that morning like thinking, I just left Yahoo as an executive, where one of my major peeves about it was all these meetings where uninformed people would just argue with each other about their opinions. And I arrive on my first day of Google, and here I am in exactly the same situation. And yeah, I was kind of bummed out about it. So the thing that I wanted to do was I wanted to say, well, look, the problem here is that not that we don't have really smart people in the room. We have really smart people in the room. The problem is that we're all just guessing at each other and then trying to position and advance our guesses over each other. So what would it take to go have a direct experience of the thing that we were talking about? Like, what would it take to just build a heads-up display and then have people kind of walk around and see what it's like to have the display in different colors? So I set out shortly after that meeting to go build the first working prototype of it. And usually when the audience is live, like right now I'm just like talking to my computer, which is weird. But then I asked them how long they think it took to build the first working version of that heads-up display. So I'll give you like 2 seconds to think about it, because I can't actually ask the audience, but there we go. So the answer is it was working by that afternoon. And it looks something like what you see over here on the left. That's Larry Page wearing it a couple days in. And it's a really simple build, actually. It's a tiny piker projector attached to a sheet of plexiglass, which holds up a screen a little bit away from your face. This is actually the second one I built. The first one I built was actually on the head, but it turns out that when something is this close to you, you can't focus on it without special optics. So this is the second build, which put it at a far enough focal distance that you could walk around and see the thing clearly, as well as while continuing to see the environment. Then the secret sauce is this coat hanger, because there's a loop of the coat hanger that goes behind the neck, holds it up, and then the other loop of the coat hanger allows this to, little compressional force allows it to rest on the chest. And the piker projector is then connected to a netbook, which then allows you to project whatever the heck you want on there. And the very first thing I did was I typed in a paragraph of text, and I cast it into every single color so that we could just compare which colors were the best. Now, that morning, like I had said, Sergey had already decided for us. Like, after a bunch of people guessed and made their arguments, he said, well, it has to be the color red. And when pressed for why it needed to be red, he said, well, red photons are the least energetic, so that's going to be the least strain on the retina, which is kind of plausible. And then the other reason that he said that it needed to be red was, well, it's always red in science fiction, which I thought was a terrible reason. But anyway, that afternoon we had a working version of a heads-up display. So the very first thing I did was I called over a bunch of people that had been in the meeting that morning, and I said, hey guys, just try this out. Let's go check, let's just check out what it's like to walk around and try to read this text floating in front of you in different colors. And as soon as people actually tried it out, as soon as people had a direct experience of the thing, all the issues were cleared out instantly. It turns out that red is absolutely the worst possible color for a heads-up display. The only exception is if, like, in the middle of the night, red is better. But in all other conditions, red is just terrible. And it's the worst by far. Second worst is purple. Best is white, light blue, light yellow. Now, if you think about it, if you think back to that meeting in the morning, there's actually no way that we could have possibly resolved that, especially with that level of specificity, knowing the feel of all those colors and kind of the stack rank of which ones would be most effective. But by having the direct experience, literally everybody who tried this direct experience, within 30 seconds to a minute, they basically come to the same conclusions about which colors were the best and which were the worst. And the difficulty in the morning wasn't that we weren't smart people in the room. Everybody was super smart. It wasn't that we weren't trying to advance logical arguments. All of us were advancing logical arguments, about the strain on the retina, or different experiences that they had, designing transparent displays, and so on and so forth. But none of them were actually working with the direct experience of just being able to walk around an environment with a transparent heads-up display on. And that basically settled the issue within minutes. All right, so a really important debug for everybody is, ask yourself when you're guessing, when you basically just have a conjecture, versus when you're basing something off of a direct experience. And the best direct experience is obviously the one of the product itself. You can always try to extrapolate from a direct experience that you had from a previous product, but pretty quickly you can get into the zone of guessing or conjecture from there. But just having that distinction and really making a commitment to yourself to reason with direct experience, I call the process reasoning with actuals, will allow you to move tremendously faster. Like I said, this was resolved in a minute, as opposed to 45 minutes of arguing with the color that morning. All right, we got to keep moving because there's not enough time. So debug number 2. So thinking about your tool chain, a lot of times people think about the tool chain and it's really just like, okay, what does my build system look like? Well, how do I push things to the server, and so on and so forth. And all that stuff is great. But I would actually kind of toss out this idea of a design for adaptability versus a design for efficiency. Like, a lot of us are used to producing production systems where it's all about design for efficiency. Like, what's the latency of this call to the server? What is the, how much do I need to have pre-computed a thing in order to be able to go serve it? Like, how do I optimize cache versus disk versus what have you? And this is all kind of a design for efficiency type design. But there's also another concept, which is design for adaptability. And I'll give you like a really specific example of that. So, a little ways into the project, we had a trackpad on the side of the head, and it gave us a huge amount of flexibility on how to interact with our screens. But because of it, there was like 50 ideas that we had for how to structure the navigation for Google Glass. Now, we could have just said, we could have just done the classic thing of just argue with each other until we like basically, by fiat or by democracy, we end up with one of the 50 that we are going to go do a real build on. But whenever you go build out a navigational structure, even if you're really fast at coding, if you need to build an entirely new one from scratch, it's going to take you at least a couple days, maybe a week or week and a half before you kind of have enough of it there for you to have a real direct experience of it. And if you had like 50 of these ideas, then all of a sudden it's going to take you an entire year to try all 50 of the ideas. So what we did instead is we took a step back and we did a type of tool chain engineering that was focused on a design for adaptability. And the design for adaptability, basically says, well, given that I want to try more than a certain number of navigation approaches, let me go design some code that allows me to try those approaches as quickly as possible. So this is not even the code itself, and you'll see that in a moment. This is the code that allows you to make code like that incredibly quickly. So what did we do specifically? We actually made a simple little web interface, and all that you could do in that web interface is you could click import screens. This is a schematic. I asked Aaron, who had coded this, like if he could find it for me, but he's like, Tom, that was like 5 years ago, so he wasn't able to find it. But it looks something like this. You click import screens, and you can basically import a bunch of screenshots that you've sketched up of different screen states from your navigation. As soon as you import them, they just pop onto this canvas over on the right-hand side, and you can kind of drag them around wherever you want. And then between different screens, you can drag an arrow, and as soon as you've dragged an arrow, you can select a number of trackpad options, like single tap or double tap or swipe forward or swipe down or swipe back or swipe up or so on and so forth, in order to go demark the transition from one screen to another screen. And then once you've kind of laid this out, you can click upload to device, and it will kind of pump it out to our current, at that time, like our most up-to-date version of the Google Glass hardware. And as soon as you have that, you basically have these screens. You single tap, it moves to screen 2. You single tap again, it moves to a different screen, so on and so forth. So you're getting exactly the feel of what the navigation would be like. But this basically brought the time down to go try a navigational scheme from, let's say, just shy of a week of just doing some pure original coding on the thing to about 15 minutes. Because all we needed to do is sketch out the screens, upload them, drag these arrows between them, which wasn't instant, but took maybe 5 to 10 minutes to go do. And then you upload that to the device, and you can now have a direct experience of what it's like to go navigate through a set of screens using that approach. Now, doing that, instead of taking a year to go try 50 different navigation schemes, we're able to try 50 navigation schemes that week. And from there, we're able to get a much more refined sense of how the data should be organized, like the information architecture, the pros and cons of different things, like how tap-heavy or swipe-heavy should a thing be, how many things should be automated and have a time-based transition, so on and so forth. A lot of really deep considerations actually got worked through in those 50 iterations. And the key here was that we went and wrote this specific piece of code. This to me is toolchain code. And my very obscure title for this is, whenever you're going to go do something more than 3 times, you can build a toolchain for it. So basically, it took us a day and a half to write this web code to be able to upload these screens and draw some arrows between boxes and label them, and then obviously tie each one of those actions to the trackpad action and upload it to the device. So it's like a day and a half of investment. But after that day and a half, we were able to go try 50 different navigational approaches within the following week. So ultimately, that day and a half toolchain investment probably saved us about a year. So just to close on that debug, a lot of times we're just used to engineering for efficiency, where you know exactly what you want to do, and you're going to go make that efficient as possible. But whenever you have something that's a little bit more of an unknown, and you're going to try, let's say, more than 3 versions of it, then you might look at it and say, what's the type of tool chain that I can build that will make it so that we can try more versions in a much shorter amount of time? All right, so debug number 3. So this is a lot more of a psychological debug, and this is a painting that my wife did. And if you ever watch a painter do painting, like for an oil painter, the medium is oil paint, and they will go put a brush stroke down, and if it's not great, then they can scrape it off with a palette knife, or if they want to change the color, they can go to their palette and mix the color a little bit differently, or they don't like the application, they can overstroke it and all these sorts of things. And the time between sensing, assessment, and actuation is very, very short in the process of painting. Like an oil painter stays in the medium of oil paint. They're constantly touching, working with oil paint as the way that they're getting things done. But imagine for a second that you were an oil painter, but before you were able to do any given brush stroke, so let's say you dipped your brush in the color and you're about to go put a brush stroke on the canvas. Let's say instead of being able to just put the brush stroke on the canvas, you actually needed to stop and write a specification and go through a bunch of spec reviews, and then have that spec review go through a development review, and then triage which things will be in a particular build, and then afterwards have those scheduled for development. And once they get developed, then they go into a QA cycle. And at the end of the QA cycle, you're able to put down your brushstroke. In that world, you're not really in the medium anymore, and in that world, it's also extremely difficult to imagine what it would be like to create a masterpiece, because you're only going to be able to go lay down a couple strokes before you're done. Now, the real kind of psychological twist around this is, what is the medium relative to the things that we work on? Like, a lot of times people think that the medium for a, a developer is lines of code, or the medium for a designer is pixels or vectors or what have you. But my challenge to that kind of idea is that if you're building products that are meant to be used by regular people, or really people at all, then everybody's shared medium is the evolving psychological states that a person goes through from the beginning of that experience to the end of the experience. That is the real medium that you're working with. And there's a lot of code that you will write and a lot of pixels that you will write that will not touch that medium at all. And that a lot of that code and design work really, I would say, it just kind of misses the mark. Like, you really need to stay close to the medium of human psychology and how regular people are going to be able to understand and navigate and interact with and be empowered by the thing that you're creating. So, on any task that you're looking at, ask yourself, well, what is the medium that's at play? Like, and you can tell the medium, which thing is the medium, because there's actual stakes in it, right? Like, not just stakes within, like, oh, I designed it this way and my team doesn't like it, or so on and so forth. It's like, if you design it in a particular way, or if you code it a particular way, and the customers that you're trying to serve are impacted by it, then you're touching the medium. But a lot of times we will go believe that the specification is the medium, or the lines of code itself is the medium, or the pixels on the screen are the medium. And we really need to stay closer to how it's actually affecting the people that we're trying to serve, because otherwise we're not going to be able to. It's basically trying to paint without being able to see the painting. It's really difficult for you to build something that's phenomenal without being able to stay in that medium. All right, so this is just more of a diagram of what actually happens today. Bermuda Triangle of spec reviews and meetings, and you can also lose a lot of things. You can lose the soul of a thing in the triage vortex, and all these things make me sad. All right, so debug 4. Okay, this concept of research versus development. So really there's, if this is a kind of schematic sense of what it takes to go do something innovative, if this is time along the bottom going from left to right, then all of us start at some earlier point in time at the unknown. And after a certain amount of time, we're going to arrive at some type of outcome, but there's a huge range of possible outcomes. So a lot of what we were doing in Google X and even before in a lot of projects I had worked on was something that was like this. So there's two distinct phases that need to happen in time. One is called the research phase, and the other one is called the development phase. And we very quickly, like colloquially, research and development is a phrase as if it is like the same thing. But to me, research and development are not the same discipline, they're opposite disciplines. So what does that mean? Well, in development, you kind of know what you're supposed to make. And development is what they teach you in school, whether it's engineering school or business school or what have you. They teach you that if you have these constraints and these resources and this much time, then here's how you go really heads down and be really efficient with those resources within those constraints in order to go build that specific thing in that specific time. So basically, the character of development is something that is very narrow, but it's very deep. You go super deep, you carry whatever it is all the way over the finish line. That's the point of development, narrow and deep. But research is the opposite discipline. Instead of being narrow and deep, research is broad and shallow. So what's happening in this diagram on the research side is, in the shortest amount of time possible, you hit the widest range of possible outcomes. And then amongst the possible outcomes that come out, then the ones that are kind of less effective, you say, well, we'll put that on pause. And the ones that seem to have more to them, then you kind of diversify those experiments and hit, even broader range of possibilities in those areas. And I forgot to mention, but when we were kicking off the Google Glass project, I challenged my team. I said, and the team was tiny at the time. Like I said, I started when there's only like a dozen people in Google X. But I told my team of 2 other people that we were going to go build 15 hardware prototypes every single week for the next 10 weeks. So 150 hardware prototypes in 10 weeks. And that's a perfect example of going broad and shallow, right? So in a very short amount of time, we're hitting a wide range of possibilities. And if you've seen my other talks, you saw me, stuff made out of chopsticks. I had lasers shooting out of our heads, and brain-controlled interfaces, and every manner of thing was tried in that first 150 hardware prototypes. But what that allowed us to do is it allowed us to dramatically improve our confidence that we had substantially explored that space and found areas that would be really powerful to kind of build off of and extend on. So there's this concept which is called a rate-based goal, so R-A-T-E, rate. And that challenge that I put out to my team was exactly that. I didn't say, hey guys, I know exactly what Google Glass should look like, and given that, here's what the outcome should be. What I put out there was a rate. We are going to go build 15 hardware prototypes per week, so that's the rate, 15 per week, for 10 weeks. And the rate-based goal, it allows you to improve your likelihood of success through successive rounds of improving your probabilities, as opposed to assuming that you already know the outcome of a thing and trying to argue for the best outcome when in truth nobody has experienced any of those outcomes. So all of that argument is basically false anyway. It's an appeal to conjecture as opposed to direct experience. So by being able to go build 150, actual hardware prototypes, we could actually have a lot of these direct experiences. And I'll give you an example of a direct experience that was happening on the research side. So as you can see, Google Glass doesn't have a keyboard on it. It doesn't have a touch screen on it. It doesn't have a mouse per se. And given that, you couldn't control it the way that you could control most devices. But at some point, I rigged up this laser projected keyboard. If you go to Brookstone, you can buy one of these. But basically, it's like a little module that you sit down and projects a keyboard onto the tabletop, and then as you put your fingers into the thing, then over Bluetooth, it'll go send the character to your device, typically your phone or tablet. But so I took one of these things and I hacked it up so that you could put it on the side of your head. And what this meant was you could walk up to a tabletop and type like this, and you could walk up to a wall and type like that. And I was like, well, this is amazing, because we don't have this, we don't have a keyboard for Google Glass, and we don't want to have a bunch of wires and have something really bulky. So just something that comes out of a tiny laser aperture would be amazing. So let's work with that. And I was super excited about the idea. I built it from about 4 p.m. to 6 p.m. one day, and then at 6 p.m. I was like, this is so exciting! You guys got to come over and check this out. So I called over 3 people from the office, and they're like, hey, what's up? And I was like, check it out! Boom! I'm projecting this keyboard, and I could type on a desktop. And I walked over to a wall, and it's like, look, I'm projecting on the wall, and I could type on a wall. And I was like, and people were like, oh yeah, that looks pretty good. That looks pretty good. And then I was like, guys, isn't that amazing? And as soon as I looked over, everybody that was watching was like, ah! Basically, I was shooting the lasers into their eyes. Now, that is the thing that, upon having the direct experience, it's really obvious why you don't do that. But that could have been on the books, in a spec, on a development plan for months and months and months before anybody discovered that that was a crappy thing to do if we had done the typical outcome-based approach to things, where we decided, oh, a laser projected keyboard is a feature that's in the build. So, in milestone 3, let's slot it in for a month-and-a-half hardware development cycle to be able to integrate it. And then we would have found out many, many months later that you shoot lasers in people's eyes. But in 2 hours on one afternoon, we were able to find out the same thing. Unfortunately by shooting lasers in people's eyes, but we didn't end up spending all this time putting the energy and speccing and component analysis and all the other things that you would need to go into this. And this is the point of the research cycle. The point of the research cycle is to go very broad, so you're hitting things like trackpads on the side of your head and lasers shooting out and a magnetometer ring where like by putting a magnet in your ring you can go control a magnetometer as a way of being able to go control a device, and just like every possible thing that you can imagine. But we were going very broad, but we were going very shallow on those things. So each one of those experiments was typically like 1 day long, maybe 2 days long. Like the brain control interface took 2 days to make. So given that, being able to go broad and shallow, we're able to, the point of the research phase is to explore as much of the space as possible in the least amount of time. And by doing that, the 150 hardware prototypes, we really touched a bit of everything, and we found these things that we called stars. And stars are these like really standout experiences. So I'll give you a couple examples of stars, and then we'll close up on this slide. So one star was in a previous version of Google Glass that covered both eyes. Like we had made a prototype where we just plugged in Street View data. And instead of like navigating Street View where like you put your mouse on the street and you double click to go forward and then you click this other thing to go turn and what have you, the interface for it was like really obvious and simple, which is when you turn to the right, you see the Street View tiles that you would see if you were to turn to the right. When you turn to the left, you see the Street View titles that you would see if you were to turn to the left. Done. So this prototype got made, and like always, we called over like 5 people from the office to go check them out. And the first person that put them on, they're like, okay, yeah, so what do I do? It's like, well, just call out a place you want to go, and our operator will go type that in, and we'll teleport you to that place. And I'm like, sure, we're in Mountain View, so take me to San Francisco. So operator's like, San Francisco, boom. And then, boom, and all of a sudden the tile's coming around the person, and he starts looking around, and he's like, holy crap, there's the ferry building. And then he looks by and he's like, there's that weird arrow thing. And then, there's that complex. So he's looking around, and he actually is like starts like getting super excited about this, like looking everywhere. And a thing that you may or may not know about Street View data is goes all the way up to the sky, and it goes almost all the way down to your feet minus a cone of maybe 15 degrees around your feet. So like you can really pretty much look everywhere. Now, after kind of looking all around San Francisco for about 15, 20 seconds, he was like, wait, take me to London now. And he's like, poof. So the operator typed in, took him to London. And he's like, whoa. And it's like, take me to Sydney. Take me to my old apartment. Take me to whatever. And it's like, this whole time, like this guy is hogging the thing, and there's like 4 other people waiting to be able to go use this prototype. And like, a couple minutes into it, we're like, hey, there's like 4 other people waiting. Like, can you like put that down for a second and somebody else could try it now? And like, no, just give me one more. And it's like, okay, that's an example of a star. That's like a breakthrough experience that is so notably different and better than the ways that you have done something in the past, that you put a little star on it. And typically you want to preserve a bunch of these stars in order to go define what your product is. Another star that happened with Google Glass, and this is a much more low-key example, but it's like I wrote like a really simple hack that where you basically call to a quote server, so like famous quotes throughout the centuries. And all it would do is like every 10 minutes it would fade back the old quote and fade in a new quote. And this is on a one-eyed version of Google Glass where the display is above eye line. So it's very similar to what is out there today. And most of the day you're ignoring it. But like whenever you've like finished doing some email, or you've finished like building something on the lab bench, I would like lean back and I would be bombarded with this ancient wisdom, like Socrates or Confucius or Emily Dickinson. And like I jokingly named it the anti-Twitter, because these are pearls of wisdom that have lasted for hundreds or thousands of years, as opposed to a trending hashtag which is dead in like 2 hours. So, but wearing that quote server in my eye, I had like the 2 most profound days of my life. Like I couldn't see normal reality in this, superficially anymore. It's like all the things that I looked at were super, super deep. There was so much connection to it. It was really profound, actually. And if you had had lunch with me on any of those 2 days, and you were like, pass the salt, I'd be like, sure, I'll pass the salt. But have you ever really stopped to think about salt? And it's like, I don't know. It was amazing, actually. Now, I consider that a star as well. It's this really standout experience I had not had with technology before, and it was really doing something that was important and interesting. Now, at the end of the day, with 150 hardware prototypes on glass, we ended up with 40 stars, which is a lot of stars actually. And a lot of times, your product people or your engineers or whatever will be like, well, all these things are amazing. Let's just jam them in the box. Like, we'll just put 40 amazing features in it. But I make that akin to, like, imagine you were looking at the night sky and you wanted to go make a constellation out of every single star in the night sky. It would just like look like nothing. It just looked like a big scatter of noise. And that happens with products too. Like, a lot of times if you have too many things or ideas or too many, like, highlight points, then it just looks like nothing. So at the end of the research phase, you do a process which is called constellating, which is, instead of like putting all the stars in the night sky into one picture, you pick like 3 or 4 stars here and 5 stars over here and 2 stars over here and 3 stars over there to form these constellations. And with 150 hardware prototypes, 40 stars, we formed about 4 or 5 constellations, and one of them we chose to move into the development cycle, which is what we've got right there. All right, last debug, and this one should be pretty quick. So you guys are probably pretty familiar with the idea of pre-compute versus runtime, and then you're smart developers, so you have like little scripts to speed things up and all that sort of thing. But if you take those concepts out of the digital world and you apply them to life broadly, then you can also get really powerful outcomes. So over on the right-hand side looks like just a jumble of crap, but it turns out that I'm a musician and I've been in a bunch of bands over the years, and I've got lots of musical instruments and effects processors and synthesizers and what have you. And whenever I would want to work on music in the past, it was like kind of annoying because some of the stuff was in the closet and needed to be set up. This would need a special cable. Amongst the things that were set up, they weren't like set up in a consistent way, because I would like do some work sometimes and like leave it in a state that wasn't like ready for the next time. And I started to challenge myself. I was like, my runtime on this is terrible. It's like, what if I were to look at the latency of my runtime relative to beginning to write music and made that a real metric to go optimize? And the big stroke of insight, which is basically what this little circle is on, is I basically consolidated a bunch of power strips, connected up all of my musical instruments so that there was one master switch that I could turn on. And as soon as I turned on that master switch, every single instrument would be ready to go and in recording mode. So I went from taking at least 5 minutes to go set things up to do a recording session to 10 seconds. Reach down there, flip the switch, everything is live, and double click, click the software to begin recording, and everything is go. So the same ideas that you have, like scripting your virtual environment, you can move them into the physical environment. And another way that I improve my runtime is that every single week, at the end of the week, and it's done on at Fridays at 10 a.m. for a very specific reason. I go write down the 3 to 5 things that I got done in the week, and then in the left-hand column. And in the right-hand column, I write down the 10% better. And what 10% better is I just look at everything that got done, the 3 to 5 major things that got done, either by myself or my team in the week. And then under the 10% better column, I write down what is an experiment that I could run next week that would make this thing 10% better. And 10% better is a mental hack, because what happens is, a lot of times we do things and we think that they're good enough. And because we think that they're good enough, we stop working on them. But no matter what you've done, no matter how good you think it is, you can probably imagine a way for it to be 10% better. So the 10% better is a mental hack because it gets you out of the routine of something that you already think is good enough, and you might try to improve it a step. Then the other mental hack is that on the flip side of things, when something is super broken, oftentimes people want it to be 10 times better or 100 times better. But like when you try to take the huge leap from where you are today to 100 times better, then a lot of times you don't do anything at all, because it's so overwhelming to try to make something 100 times better that you're just stuck in theory land. You don't ever put it into practice. Now, the beauty of 10% better is it deals with both of those mental conditions because it kind of unsticks you if something works well enough, and it also unsticks you with the daunting task of something that's working super poorly. But the other hack in there is doing it at Friday at 10 a.m. And the reason is that let's say you've written down what you've done in the left-hand column, you've written down 5 experiments that you can do next week in the right-hand column. Well, because it's Friday at 10 a.m., then after you've done this exercise, which only takes like 15 minutes, then because Friday is still a work day, you can implement all the easy ones literally on that day. So a lot of times I'll like go and like write a script, or I'll talk to a person, or I'll modify a thing, or I'll put something on the schedule that's going to force me to do that 10% experiment within the day. Or if it's a harder change, like it requires reorganizing your team or a new process for this or that, well, because you did this on Friday, you have the entire weekend to go think about it, so you can actually implement it the next week on Monday. And a really kind of obvious thing, but if you do this every single week, the 10% is compounding. And you guys can do the math, like 1.1, so 10% better, 1.1 raised to the 52nd power, because there's 52 weeks in a year, is like 130 times better. It's like way, way better. And you get there by compounding these little 10%, basically constantly improving your runtime, even on things that you think are good enough. All right, so with that, I think that is the end of the presentation. I'm going to move into Q&A. This is my team on day 1. This is my desk after a week and a half. If you want to follow me, I don't tweet very often, but you can at least get in contact with me. That's that thing. And all right, I'm going to break out a screen share and go to the questions now.
Great, Tom. Wonderful presentation. Very interesting, very enlightening. And while you've been presenting, we created a few polls here. I don't know if you can see them. Just kind of curious about what the audience thinks about Google Glass and their hardware programming experience. Got some interesting results here that we'll talk about.
Cool.
So about 1 in 5 audience members have tried on Glass. 4 out of 5 have not. The number one kind of fashion take on Google Glass has been nerdy. Nerdy has been the fashion kind of view of Glass. Indifferent and cool coming in 2nd and 3rd.
Cool.
Looks like the audience has a variety of programming experiences. Looks like no hardware programming experiences was the number one answer, though. Got mostly software developers here, but there are a variety of hardware developers as well that have programmed on a variety of technologies such as Glass, Arduino.
Yeah, I see Pi and Arduino. Those are great. Mindstorms are okay.
Yep. And future of personal computing. Looks like it's pretty close between smartphones and head-mounted displays such as Glass. Watches is a distant 3rd, so not a huge audience group that thinks that the iWatch kind of related technologies are going to be the future. Maybe it's kind of complementary to other technologies. And then the last.
Yeah.
Sorry, go ahead.
Oh yeah. So okay, actually, we'll just do the last poll then. Sorry. And
yes,
then,
the last. So most software developers looks like they are shooting for good enough when they write their code. That's the number one answer. Second answer here is that the second group of people thought that they would kind of take your advice and go for 10% better. And then the smallest group is shooting for a ridiculous extreme up to 100x better. So
yeah, here's the irony about that, which is so good enough is great, so get good enough in the first place. But as soon as you get good enough, especially if you are going to go do that operation more than once, you should ask yourself 10% better. But all these things are connected because by doing a bunch of 10% betters, you achieve 100 times better. And that's actually kind of what I was legendary for. This is probably an overstatement. No, it's probably not, because a lot of people I'd never met would come up and be like, you're the guy that did this. But like in Yahoo, I would get stuff done like 100 times faster than people believed was possible. And it was really just a combination of a bunch of 10% betters over enough years. Okay, with that, I'd love to jump into some of the questions because we've only got about 13 minutes.
Yep, so we'll just start from the top here. So the first question with the highest number of votes asked by Aditya Chaturvedi, who also is the winner of our lottery for winning a free mentoring session over Hack Pledge for asking the question with the most votes. There is a buzz that Google Glass is failing as a project. How much truth is in that? What do you think, Tom?
Oh, this is great. And actually, I see the first 3 questions are very related, so I'm going to kind of answer all of them in an omnibus answer. So Google Glass right now, you have to realize it was created out of basically cell phone components. And cell phone components are, they're very small compared to what existed before. They're small then compared to what used to be in desktop PCs, but they are still quite large for something like a pair of glasses. And it means something like, oh, if you want to have a camera modules are like 5.5 millimeters on a side, which is like kind of tiny, but actually kind of big for a heads-up display. Now, as you actually start to create some type of market for a thing, and it doesn't even need to be a huge market. Let's say glass is shipping between 10,000 to 100,000 units per year, which, I mean, it's already shipped over 10,000 units, so it's totally believable that it can ship in that range for a couple years. Then even that amount, even 50,000 units a year, gives you enough volume that you can go back to your component providers, and then you can do what's called component supplier pressure on those providers. So if a 5.5 millimeter camera module is too wide, you can say, hey, we're going to be shipping another 200,000 of these over the next 3 years. Can you do the tooling work that it would take to go take this camera module from 5.5 millimeters on a side or 4.5 millimeters on a side to make it 2 millimeters on a side? Can you do that with the optics chain? Can you do that with the light engine? Can you do that with the by making a 8-layer board instead of a 5-layer board, and so on and so forth? And to the extent that you've got enough units moving, and enough really is in the zone of, let's say, 10 to 20,000 up to 100,000, then that's enough actually from the capital requirement side to be able to provide component pressure that will allow you to shrink those different components. So what this means is that if a number of the key components in Google Glass can be shrunk by, let's say, 3 to 5 times in terms of physical volume, then it will allow Google Glass functionality to exist in basically regular pair of glasses, something that's the same size as a regular pair of glasses. Right now we've jammed pretty much everything that a cell phone can do into something that's about 1/3 the volume of a cell phone or 1/4 the volume of a cell phone. But like, you really need to bring it down another 4 to 5x in terms of volume to fit into just a regular pair of glasses. And at that point, Google Glass, I'm not sure how much everybody's glasses cost, but like my glasses cost like $350. Like, glasses are already sold at a device price point, not because of the manufacturing costs. It's because Luxottica is this huge global monopoly that which charges these huge markups. But it doesn't even matter. It's like people are used to paying, whatever, a couple $100s for their glasses. And given that glasses are already at a device price point, in the future, let's say 5 years from now, with enough component pressure, you could have the choice when you're buying a new pair of glasses to either get a $350 pair of glasses that is a pair of glasses, or you can get a $350 pair of glasses that also has Google Glass style functionality inside of it. And I think that's kind of the threshold at which it's like the mainstream adoption will come.
Yeah, that's really interesting, actually, Tom, because I see a lot of analogies there between buying a regular watch versus buying an Apple Watch. In terms of, you can have a wristwatch, but do you want the enhanced functionality? So it's a very interesting analogy there. Now, one kind of question I have for you here is, let's say, there's been a trend over the last decade or two towards laser eye surgery and LASIK. I got laser eye surgery myself. Part of it was convenience, part of it was fashion, a little bit of both. In the future, if the components shrink, do you think that there may be a resurgence in folks wearing glasses? And if not, what other kinds of technologies or kind of frames could go on your eyes? Would it be something other than glasses? Like, what do you think it would look like for people who don't want to wear glasses?
Yeah, I think that's actually a really interesting question. And obviously, Google X is also the division in the world that is the best at embedding stuff inside of contact lenses. So you could get to a zone where you basically just have all that in your contact lens, though, without getting into a huge amount of detail, because there's a huge amount of detail to be able to go put all that into a contact lens. There's a good amount of work there in order to fit that all in a contact lens. Because if you think it's difficult to bring the volume down by 5x, imagine bringing it down by 50x in order to go fit in that type of volume. But details, we'll put that aside for a second. I think glasses is a good target in like the next 5 years, because that is a very fashionable form factor. So a lot of the issues about like, is it nerdy, is it fashionable, or whatever, just goes away because you are slipstreaming into something that's already a well-established form factor and kind of fitting the design constraints of that form factor. And what Google really needs to do in the interim, which is kind of already in play, is that it needs to be able to float a market that can support 10 to 100,000 purchases of this type of technology per year for the next couple years while the component pressure plays through and shrinks different elements of the device. And where those usages will be places that have very kind of intense real-time data needs. So an example that I've shared with a bunch of folks, and this is tested and researched example, is for an anesthesiologist. So an anesthesiologist needs to be injecting anesthetic and be paying attention to the point of injection, but they also need to be paying attention to the vitals of the patient. So typically an anesthesiologist is injecting, and then they're looking back at the bank of vitals on the wall, and then looking back at you, and then looking back at the vitals, and looking back at you. Now, people would just make less errors if they have a heads-up display and they can just see the vitals while paying attention to the patient. And similarly, applications like for factory workers that are doing pick and place and other factory tasks, technicians that need to go service engines and all these sorts of things, like the real-time information about the status of the system while you're maintaining the system is kind of a huge boon for those sorts of folks. And it can easily float like a 10,000 and above market. Like even just the factory worker thing, Foxconn has got 1 million employees. So you could cover all the actual demand that would be required to provide that component pressure just building apps for Foxconn if you wanted. Great. So that got rid of the top 3. That's great. Why am I not wearing Google Glass right now? That's great. So I think I actually kind of answered the question right there, which is it is best for, there's really 2 modes that's best for. One is intensive, like amplifying a task at hand type thing. And then the other situation is just an ambient awareness of a thing. Now, when there's situations where I am super on task, or like when I want to have a specific reference in my eye and I don't want to be down at my phone or don't want to be chained to a desktop or a laptop, I want to be mobile, then I do whip out the glass. And I also do it for hiking and other things where I just want to be able to capture my experience. So those are the situations I use it for. It is a lot more kind of situational, it's triggered by specific situations, the usage right now. And I think because of it, the net usage of it is a little bit less because you either need it to be like the default, where it is your regular pair of glasses, and the people that have bought it with prescription do use it a lot more. So like that hypothesis is proven out. But the more that it's just like your regular pair of glasses, you don't even need to think about it being glass in the situations that you don't need it to be, then that's a place that you can get to. Or you need to be in an environment where many hours of the day, like a technician or a factory worker or a surgeon or an anesthesiologist or whatever, where you really need this real-time information, or a Wall Street trader, what have you, right? Like where you really need this real-time information. For those people, that's like the right first market for it.
Right, we've got about 4 minutes left, Tom, so anything you want to rapid-fire answer here?
Okay, let me see. I would just try to run through. What is the future of Google Glass and law enforcement? Oh man, like people always do the scary scenarios, and I think scary scenarios are also real. But the reason that Glass has got a camera is that by being able to go see through another person's eyes and hear through their ears, it is like one of the deepest ways of building empathy. It's probably the deepest way of building empathy I've ever experienced. And my mom is like a Buddhist, so I spent all this time cultivating compassion and all this shit. So that blows all of that meditation out of the water. Like being able to really see through somebody's eyes and hear through their ears is amazing. And that's the reason the camera is there. Now people, yes, are using it for surreptitious pictures and recordings and what have you. That's not really the fucking point. But at the end of the day, people will use it for what they want to use it for, and sometimes it's not what was intended. All right. What is new on the horizon? Design functions. There's over-the-air updates, so you should just keep on top of those. There's too many things to go look at. Will we see augmented reality features? Yeah, the other reason for the camera, of course, is that you can do augmented reality. So, for example, you can see a sign that's written in Japanese, it can be automatically translated. Or the people that are blind can kind of walk around and have the bone conducting transducer tell them about the environment that they're in, or tell them when there's faces in front of them, all of which are great sort of inputs for people that are impaired in some way. So for a number of reasons, we're going to get a number of augmented reality features. So that is coming. All right. And then, of course, the biggest difference between Oculus and Glass is just the mobility aspect of it. Because Oculus, you need to be connected to power and you need to be connected to your computer. Since Glass is a standalone device, you can just like walk around environment with it. But I think both are pretty phenomenal platforms. So you just let that stand. The biggest problems that people react. Yeah, so I think I answered this question first, which is yes, it does look a little strange because it's made out of cell phone parts, so it's still a lot bigger than we want. So once it gets smaller, I don't think it'll be that strange looking. Though Isabel Olsen is an amazing industrial designer, and she really did a great job for what we gave her. So props for that it's as fashionable as it is right now, despite the fact it can be much better. Is it true that Google Glass causes a lot of stress to your eyes? No, not really. It's not like, even though it's up close to your eye, it actually creates a virtual image that's 2.5 meters out. And 2.5 meters, up through 4 meters is the natural resting distance for the focal distance of your eye. So it's actually put at a focal distance, which is the least possible stress. I think you might be talking about monocular cognitive stress, which is a slightly longer topic, and I will not have enough time to answer that. But it's the stress that you're talking about is, yeah.
Okay, great, Tom. Looks like we're just about out of time here. I want to
Okay.
thank you for everything. It was wonderful, wonderful presentation. Very enlightening and interesting. So thanks to Tom Chi for being generous with his time, being here today. He's actually video conferencing in from a secret mansion in San Francisco called The Factory. And so it's a very interesting environment that he's in there. You want to give us a quick look around here, Tom?
Yeah, it's like crazy out there. Anyway, I'm going to sit back down.
This is where Tom Chi hangs out. I come there every now and then too. It's a great, great environment for startups. So, so just real quick, logistically, we're going to. Oh, go ahead.
Yeah,
Tom.
I did want to say one other thing, which is there's a Get Involved tab that you guys can click, and I want to encourage everybody to go do the Hack Pledge. And if this was helpful to you, or you're getting something from the conference, to donate, since all these donations go to support nonprofits that teach others to code.
Great, thanks, Tom. We'll be back in just a few minutes. Feel free to go to the bathroom. We're going to be back very soon. Cool. And by the way, the next speaker is going to be Bram Cohen. He is the inventor of BitTorrent. And so it's going to be a great presentation by him. Very hardcore, yes. He's going to be talking about the BitTorrent Live protocol. It can be very interesting. So thanks, Tom. We'll see you guys in a few minutes.
All right, thanks, Ed. See you guys.